data structures using C, deleting a node from a binary search tree. In this lecture, you will learn how to delete a node from a binary search tree and implement this algorithm to delete the node from the binary search tree. There are three possibilities in the deletion of a node from a binary search tree, or three cases we say. Case one is deleting a leaf node without any child nodes. Case 2 is a node with one child node, and case 3 is a node with two child nodes. So let us get into each one of these cases. So first one is deletion of a leaf node or node without child nodes. For example, here this is a leaf node, this is a leaf node, this is a leaf node, 70 is the leaf node, and 90 is a leaf node. Now the question is, how do we delete these leaf nodes? It's very simple, simplest of the algorithm. So what do, for example, I want to delete 90. So this is the one I want to delete. To delete 90, that means I have to sever this link. That is, this when I search for 90, I come here, this becomes current, this becomes previous. Therefore, previous next, it is previous right. If previous right is equal to current, that means both the addresses are the same, then this has to be deleted. Then I say previous right is equal to null. So that is how we remove that. Similarly, we could do any one of these leaf nodes could be easily deleted. We come to case 2. Now we have to search for a node with one child node. As you see here, this is a node which contains one child node, whereas 80, 90 and all the rest have two child nodes. So how do I delete 60? So first of all, I search, starting from here, I search for 60, I come here. This becomes previous, this becomes current. So I have to replace this current with either the left on the right or left node on the left. Now in this case there is only one node, 70. So therefore I replace it with the 70. I just put this address of this node here. That's all. I assign therefore previous left is equal to current. So that is what I do, and automatically then free this node. With that I have deleted the leaf node. In other words, in that they deleted a node containing one leaf node. Now we come to case 3. This is little complicated. Now case 3, we have to identify first of all the nodes which have got two, as you see, two child nodes or two leaf nodes are there on the right and on the left. Let us identify those. For example, 80 is a node which has got two leaf nodes. There is a subtree here and there is a one right leaf node. We have got 30 here that has got two leaf nodes which could be deleted. This, when you delete this, either I put this one here or I put this one here, any one of these. Or here 20. So while deleting 20, I can put 10 here, or I could put 25 there. We'll come to that. Yeah? Or I have got 50, I could delete this 50 and then delete it with some other number. So these are, first of all, let us identify these 4 nodes which have got two child nodes, or two, in this case there are two subtrees are there. So how are we going to delete this node? We will take the first example of 50 itself. 50 is the root of the tree. I want to delete that number 50 and replace with which number is the question. Should I replace it with 20 or 30, 10? That is the question we have. So we have to solve that question first. So in this case, whenever we have a node with two child nodes, what we do is either we replace it with the in order predecessor. In this case, as you see, in order predecessor is 40. In order predecessor. So then I replace it with 40, and then I remove this child node. So this is how I do. One more possibility is I can, for example, can replace it with in order successor. For example, here I've got the 50 as the leaf node here. What is the in order successor? As you come here, this becomes the in order successor. because that is 40, 50 is the next. Suppose 50 was not there, would have had to replace it with 60. So that is in either in order predecessor or in order successor. So for example, I replace it with 50 and I remove it. So as you see, therefore, the binary tree remains as it is: 10, 20, 25, 30, 50, 60, 70, 80, 90. The in order traversal is correct. So in this case, we are not going to put the address of this node here. We are just going to put the value there and remove this node. That is what we are going to do.